Alright guys, welcome back to this channel, and in this particular video I'm going to be showing you how to get the limit of particular sequence, and also to use epsilon argument or epsilon definition to prove that this limit we've guessed is actually a correct one. So if you are new to this channel, don't forget to click on the subscribe button, right, so that you can be part of the family. This is where this is how we get encouraged to know, okay, people are actually following what we are doing. So let's go to question one. We want to first get the limit, because remember, for example, if I want to use epsilon definition, remember that I have to know that for all epsilon greater than 0, there is n by epsilon, right, in n, such that the absolute value of xn minus l less than epsilon, right, for all what n greater or equal to n by epsilon, right? So now, for me to use this definition, I need to know what the limit is. That's what I want to first of all achieve. Okay, so let's achieve what the limit, then we can now apply the epsilon definition, shall we? Okay, so let's quickly do that. I want to find the limit of, let's find the limits as n tends to infinity of the square root of n squared plus 1 minus n. Now, if I should put limits, the limits into this question, for example, if I should have infinity squared plus 1, that's going to be the root of infinity minus 1, that's still infinity. The root of infinity I cannot tell because I don't know how large it is, but I know it's going to be an infinity. Minus n is still infinity. And well, our assumption is not really on a clear basis. So what I want to do is we want to approach it in a very wise manner. Okay, so what I will do first is that I will take the conjugate. I will do the root of n squared plus 1, then plus n, okay, over the root of n squared plus 1. This is going to be plus, then plus n. Okay, so it's still like saying over 1 over 1. So if I should multiply this all together, I should have something like, as n tends to infinity, this is like difference of two squares. So that would be n squared plus 1 and a minus n squared. Okay, that's difference of two squared over square root of n squared plus 1 plus n. And obviously this cancels this. So I'm left with the limits as n tends to infinity, okay, 1 over the root of n squared plus 1 plus n. So what do I do from this point? So let me just divide all through, basically, and we can now finalize whatever we want to do. Okay, so suppose I want to divide all through by n. So if I say n tends to infinity and I divide this by n, that means I divide both numerator and denominator by n. So I'll be having something like this: plus 1 over n plus n over n, right? Okay, so we can now use the idea that the limit as n tends to infinity is 1 over n over, now you know that you agree with me if I should say that n is the same as writing the root of n squared. Do you agree? So that means if I want to rewrite this particular section, I will write it like the root of n squared plus 1 over n squared, because if I should change this n to this, then using such root of a over root of b will lead to the root of a over b. Do you agree? That's what I actually did there. Okay, so plus n over n is actually 1, right? So yeah, That's very, very easy to approach. So what would I do next? I will simplify. The limit from n to infinity is now 1 over n over the square root of 1 plus what? 1 over n squared plus 1. Now we can put our limit and we are sure that we are doing the right thing. So if I should put the limit, that will be 1 over infinity over the root of 1 plus 1 over infinity square, which is still infinity, plus 1, right? And 1 over infinity is actually approaching 0. That's 0 over the root of 1 plus 0 plus 1. So because we already have numerator equals to 0, our limit L is equals to what? Is equals to 0. Okay? So our limit L, we have been able to get the limit to be what? To be 0. So now, how do we now prove this? That's what we're going to do quickly in this next step. How do we prove it? So now the next step is to actually get the next step is to actually get to prove that this 0 is a limit, right? We want to show that it really converges to 0. So I'm going to be using the epsilon argument. So how do I go about that? So let's quickly clear what we have on the screen. So okay, yeah. First, I want to even know what is epsilon argument. So which is for all epsilon greater than 0, there is n by epsilon in n such that by the time we take the absolute value of the sequence minus the L, our answer will be we will have a capital N that is greater, that is less than what? Epsilon. And our N is greater or equal to N by epsilon, right? So what we just need to do is to fix in everything and get our answer correctly. So let me fix it. What's my xn? My xn is actually the root of n squared plus 1 minus n, then minus 0 is our limit, right? It's less than infinity, and less than epsilon, right? So now, which means the absolute value of the root of n squared plus 1 minus n is less than epsilon. So this doesn't really make any sense if I don't actually take the rationalization serious, just like I did earlier when I was trying to get the limit. So what I'm going to do now is we can do the rationalization, and remember, if you check earlier, we got something 1 over the root of n squared plus 1 plus n. That was what we got when we rationalized, right? So we don't need to go through that process again. So it's less than epsilon. All right, so the next thing I want to do is to find a way to get this particular condition intact. Okay, so what I will do now is take away the absolute value. So I have 1 over root of n squared plus 1 plus n. Now, this, if I should do comparison, is actually less than if I should do away with the n, right? So it's actually less than the root of n squared plus 1 because it's easy to remove because we are talking about plus. And this is actually less than epsilon, right? So take the square of both sides. I'm going to be having 1 over n squared plus 1 less than what? Epsilon squared. Okay? Now, since I've been able to do that, if I should take reciprocal of both sides, what would that be? That would be n squared plus 1 will be greater, right? Greater than 1 over what? Epsilon squared. Okay? So, if I should collect like times, so n squared is actually greater than 1 over epsilon squared minus 1. And guys, we have been able to show that because obviously we have just satisfied the condition. So n squared greater than 1 over epsilon squared minus 1. Okay, that will be what? N will now be greater square root of 1 over epsilon squared minus 1, and we have been able to show this. So true, L is equal to 0. I've been able to prove that. Since we have been able to show that n is greater than n bar epsilon. Very easy to do. So let's quickly check number 2. That's the next question. We'll first of all find the limit, just like we did for the first one. Then we'll go ahead to prove using the Epsilon definition to be sure that this is actually a correct limit that we have just guessed. So let's move into B. Okay, so before we solve question 2, if you have not subscribed to this channel, kindly do so now. Very important, right? So yeah, let's move into question 2. If I want to also compute the limit and also prove that that limit is correct, so what do I do first? I take the limit as n tends to infinity, okay? Limit as n tends to infinity of the sequence 4n squared plus n minus 2n, right? So I work on multiplying by the conjugate. So I would say this is over 4n squared plus n plus 2n, right? Multiplied by that same thing, 4n squared plus n plus 2n, okay? So that's like difference of 2 squares. So I'll take the limit as n tends to what? Infinity, right? So that would be 4n squared, okay, plus n. Then minus, if I should square that one, that would be what? 4n squared. Don't forget the difference of 2 squares over the square root of 4n squared plus n minus 2n plus 2n actually. So this cancels this. So I'm actually left with the limits of n to infinity, then n over the root of 4n squared plus n plus 2n. So now we can divide by the highest power in the polynomial. So that will be saying that the limits of n tends to infinity of n over n, okay? Then if I should divide the root of 4n squared plus n divided by n plus 2n divided by n, okay? So this becomes 1. This cancels this. Then I'm going to have the limits as n tends to infinity of 1 over, now what would this be? Remember the tactics where we solve question 1, that will be 4n squared over n squared, right? Plus what? N over n squared. Good. Then plus 2. So this cancels this, and this cancels one of this. Okay, so what do I have next? Let's clear that part away. So I'm going to have the limits as n tends to infinity of what? 1 over the root of what? Of 4 plus 1 over n plus 2. Is that good? So the limit now as n tends to infinity will now be, yeah, if I want to, let's put the infinity now. This won't be necessary. So I will now have 1 over root of 4 plus 1 over what? Infinity plus 2, which is equals to 1 over the root of 4 plus 0, right? Good, plus 2. That will be 1, root of 4 will be 2 plus 2. So my L will be what? 1 over 4. Very interesting stuff. So I've been able to get my L. Okay, so now that we know that the limit of the sequence is 1 over 4, it's now left to us to prove that this 1 over 4 is indeed a limit point. So we are going to use our epsilon definition to clear that out. And of course, we know that that is for all epsilon greater than 0, there is Sn by epsilon in n such that the absolute value of x of n minus the limit point is less than what? Epsilon. For all what? For all n greater or equals to n bar epsilon. Okay, shall we? So we pick the absolute value of the xn. What's our xn? The root of 4n squared plus n minus 2n, then minus 1 over 4, which is our L, less than epsilon. For this to make sense, we'll use the rationalized form that we used earlier while we were trying to compute the limits, and that is n, remember, n over square root of 4n squared plus n plus 2n. Okay, then minus 1 over 4. Very easy to do. So I'll go to find the LCM next. So that will be, the LCM of this is going to be 4 into the bracket of the root of 4n squared plus n plus 2n, right? So if I should find this one, that would be 4n minus, in bracket, the root of 4n squared plus n plus 2n, right? Aha, less than epsilon. So open the bracket, I'm going to be having something like 4n minus the root of 4n squared plus n minus 2n over 4 into the root of 4n squared plus n plus 8n is less than epsilon, right? So next, I'm going to simplify every of these terms. So 4n minus 2n, that's 2n, okay? So I'm going to be having the absolute value of 2n minus the root of 4n squared plus n over 4n, sorry, 4 into 4n squared plus n plus 8n less than what? Epsilon. Now we can make use of our comparison, like I said earlier. If you have something adding up in the denominator, that's just a layman word, you can always remove it out. And if you have something subtracting in the numerator, you can always remove it out. So which means that this is actually less or equal to 2n over 4 to the root of what? 4n squared plus n. This happens when you have something subtracting in the numerator, you can remove it. When something adding in the denominator, you can also what? Remove it and just make it less. Because it's actually less. Okay? So that's just a simple term to describe that. So, anyways, so I can now work with this. 2 here is 2. So I'm literally having n over 2 to the root of 4n squared plus n is less than epsilon. Okay? So what will be the next thing? Next thing is to cross multiply. That is n is less than 2 epsilon into the root of 4n squared plus n. Is that good? So let's square both sides so I can take care of the square roots. That will be 4 epsilon squared into what? 4n squared plus n. Is that okay? So I'll have n squared less than epsilon squared. That will be 16 now. Okay? That will be 16 n squared epsilon squared plus 4n epsilon squared. Right? So bringing all together, it will be 16 n squared epsilon squared. Bring this to the other side, that will be minus n squared. Then you still have your plus 4n epsilon squared, all greater than what? 0, which will be 16 epsilon squared minus 1 n squared plus 4 epsilon squared n greater than or equal to what? 0. So this is actually a quadratic equation which I can solve using my formula method to take care of it quickly. Okay, so using quadratic formula, we are going to take care of that. Don't forget what our quadratic formula, that x is equals to minus b square minus b plus minus square root of what? B square minus 4ac over what? over 2a. So implementing that, the whole of this will be my a, this is my b, there's no c, so c is 0. C is actually 0. So I would have n to be greater than what? What's my minus b? As minus 4 epsilon squared plus or minus the square root of b squared. What's my b squared now? 4 epsilon squared all squared, right? All squared minus 4ac plus 16 epsilon squared minus 1 times 0 over 2a. What's my a? 16 epsilon squared minus 1. Okay? In that case, what would that be? N will be greater than minus 4 epsilon squared plus or minus the square root of what? Of 16 epsilon 4 over 32. But let me just put it as 2 into 16 epsilon squared minus 1. So I've been able to express that. If I find the square root, that will be minus 4 epsilon squared plus or minus 4 epsilon 2 over 2 into 16. I've achieved this condition basically because I have a greater sign already, so that's fine. Let me just simplify it to the lowest term. Then we can know the value of that n in n. Okay, so I now have n greater. What's common here? 4 is common. 4 4 epsilon squared, a minus 1 plus or minus what am I doing? That's 0, right? That's plus or minus 1, right? So yeah, over 2 into 16 epsilon squared minus 1. If it is a plus, then it's going to be 0. If it's a minus, it gives us something else. So let's just conclude here. 2 in this place is actually 2. So yeah, epsilon squared minus 1 plus or minus 1 over 16 epsilon squared minus 1. So for the fact that I can get this one, it is true that my limit point is 1 over what? 1 over 4. All right, so thank you so much for joining in this particular video, and yeah, we'll definitely see in subsequent video. But before you go, don't forget to hit the subscription button, join the family so you can see more videos coming subsequently. And in this way, we also encourage that, of course, we have people out there actually learning through what we are teaching out. And until then, I will see you in the next video. Bye for now.